Okay, so let's start our session. Welcome to the session Enterprise Networking, Cisco and AWS. So what you will see in the next 60 minutes, it's basically, as always, we have security, we have networking, and we have applications. And that's what you see as points number 1, 2, and 3. So we will start looking at how to secure, connect SD-WAN and cloud. Then we will talk about global WAN. You probably saw the announcement in the morning in the keynote, right in the beginning, multiple slides, Cloud WAN. So we will show you how to do Cloud WAN from AWS together with SD-WAN from Cisco. And then we will have just one slide, but it's quite important, how to create a bridge between applications and SD-WAN. But that's not all. That's just 50% of what you will see in the next 60 minutes. Because then we have my partner in crime, Simarbir, who will present you this.
Thank you, Nikolai. So during the second half of this session, we'll be going into the different integrations that we at Cisco Meraki have done with VMX. We'll start by talking about our integration with Transit Gateway to enable deeper connectivity into the cloud. Moving on to how we've integrated with the newly launched Cloudvan for multi-region connectivity. And then finally, wrapping it up, we'll talk a little bit about security and how you can use SASE and SD-WAN to secure your workloads across different VPCs on AWS. A quick introduction on my end. I am Simarbir Singh, a technical marketing engineer on the Cisco Meraki team, and I focus on virtualization and SD-WAN. With that, I'll hand it back to Nikolai.
Thank you. And my name is Nikolai. I'm technical marketing engineer responsible for cloud topics and SD-WAN based on Viptela. So before jump into the first section, let's just clarify what do we understand under SD-WAN. I was at our Cisco booth, and sometimes you will get the question, SD what? So SD-WAN yesterday was a traditional separation of control and data plane. That's the technical definition of SD-WAN. Then you have also policy control, which means you can define SLAs, service level agreements, and you can reroute your applications over multiple links. MPLS will probably be used for critical traffic like voice, and public internet can be used for something else. And then you do also service chaining with firewalls or load balancers, for example. That's okay, that's basic SD-WAN. But that's not all. Because now we have infrastructure as a service, where you want to have cloud or multiple clouds as just another point of presence, as just another branch. You want to have the same policy across your traditional network, internet, and cloud. Then you have your SaaS applications, Microsoft 365, for example, where you ask us to do first packet match. We need to detect that SaaS application on the first packet, which is, by the way, encrypted. It's a challenging engineering task to do, and you need intelligence, you need VM or physical device to do this. And then, because your applications are growing, you need to create a bridge between applications and SD-WAN automatically. And you will see how we do it. So that's what we understand under SD-WAN today. Now, we have two different SD-WAN solutions within Cisco. We have Meraki on the left side, and we have Cisco SD-WAN based on Viptela on the right hand. And there's no one size fits all. It depends on the customer requirements. Sometimes if it's a simple coffee shop, they will take one solution. If it's a financial institution, they will have different requirements. Similar like database choice. Multiple databases because we have multiple requirements. And in that session, in the next 55 minutes, you will see details for both solutions, for Viptela and for Meraki. related to Cloudvan, related to application detection. So we will cover both. And by the way, we have even customers using both solutions at the same time, because at the end, it's just routing. Yes, they have two different management systems, but you can link two systems together. And for example, at small location, in this example, it was a rental car company. They used Cisco Meraki. And if it's a big location, like huge airport, we had Cisco Viptela. So now let's jump into the first topic, which is centralized firewall inspection and SD-WAN. And I know it's a little bit strange to hear from a Russian guy talking about security. So stay with me for 10 minutes. You will trust me, hopefully. Or not, you never know. So let me start with traditional site-to-cloud use case. You have your host VPCs connected to AWS Transit Gateway, and you have SD-WAN VPCs with two C8KV. C8KV stands for Catalyst 8000V virtual router. It's actually the same as CSR 1000V. It's Cisco IS virtualized running on AWS. That's totally fine, and we automated this. You can go to Cisco vManage, which is network management system, which controls SD-WAN and cloud, and you can automatically create transit gateway and SD-WAN VPC. You can discover host VPCs, do all this. That's great. But we see requirements for east-west, north-south, every kind of traffic inspection through the firewall. So the traditional centralized solution is to have shared sources VPC with, in our case, Cisco FTD virtual firewall, but that can be any firewall. The benefit we have in this case is you have SD-WAN and security from one hand. You have one phone number to call. You are avoiding any ping-pong games between multiple vendors. You have security and SD-WAN from Cisco. And it's scalable because we are using AWS gateway load balancers to load balance traffic between multiple firewalls across different availability zones. We have two main connectivity options if you look at the traffic flow. If you go from host VPC to transit gateway, you can have a default route or a specific route pointing to gateway load balancer endpoint. So option one will not send traffic to transit gateway. It will use AWS private link and send the traffic directly to AWS gateway load balancer. Second option is to send traffic from host VPC to transit gateway. You can have multiple route tables for separation, for true segmentation, and then the transit gateway will route the packet to shared sources VPC for inspection. Which option is the best one? It depends. It depends on your requirements, bandwidth, so there's no one golden solution. That's why I present both here. That's just a starting point. How will I send traffic from host VPC down to SD-WAN? And next slide will show you basically the rest of the packet life. So simplified version will be you go from host VPC. In this case, I'm using option 2. I'm sending traffic to transit gateway. Then it goes to gateway load balancer, to the firewall. Firewall inspects the traffic, sends it back to transit gateway, and then finally I go down to SD-WAN transit VPC, and I am in my SD-WAN fabric. Nothing special, just a standard routing. The way back is exactly the same. From SD-WAN to transit gateway, gateway load balancer, firewall. Very important, the same firewall. That's why the same? Because we need it for symmetric routing. If the packet will be sent to a different firewall, it will drop it. It will say, I don't know what it is. I don't have any contents. I will drop it. And then two last points. We call it GNIV protocol, generic network virtualization encapsulation. That's the language AWS gateway load balancer talks to the firewall. So basically the packet the data packet will be encapsulated into UDP and using Geneve sent to a firewall. That's what we need between load balancer and firewall. So the firewall must support Geneve. And second topic, that's what I mentioned, was the same firewall for symmetric routing. We need to enable appliance mode on transit gateway for the shared services VPC attachment. You cannot do it via AWS UI console. It's just the way it is right now, but you can use any CLI of your choice to enable appliance mode for shared services VPC to make sure that the returning traffic will be sent to the same firewall. So now that's simplified version. Because we have level 2 intermediate session, I included detailed packet flow. Let me just briefly go through it. It's not scary, it's not complicated, but it has 7 steps in it. And it starts with step number 2, not step number 1. Why? Well, step number 1 was exactly the option 1 or 2, how do I go from my host VPC to transit gateway? Here, I start with my step number 2, how do I send traffic from transit gateway to the firewall? So what we have here is we have transit gateway route table pointing to the endpoint. The gateway load balancer endpoint will take the packet, route it to the load balancer itself. On that load balancer, I enabled cross AZ load balancing, and I enabled Geneve. Gateway load balancer will use target group based on IP address, and that's important. You can define multiple options for the target group. You can take a VM. You can just point it to the firewall, but that will be wrong. You need to use IP address, and in this case, I just highlighted in red just, for example, the way it will take. So let's say it will take the second firewall, and this IP address 10.102.13.67. This is normally the outside IP of your firewall. So you are protecting actually your SD-WAN from the cloud. But you can also technically, it can be any interface. It can be inside IP as well. Okay, so let's assume we will send the traffic encapsulated in Geneve to the firewall number 2. Firewall will inspect this. The question is, well, Nikolai, stop. What if the firewall will fail? Do I have any health checks between? Yes, we do. You will see health check between gateway load balancer and the firewall, and you can define it. In the demonstration later, you will see I'm using just HTTP server on specific port for the health check. Firewall inspected the packet, send it back to gateway load balancer, and then the gateway load balancer will remove Geneve encapsulation, will send it back. At the end, the packet lands to transit gateway, and normally there will be a different route table. So even this picture doesn't show you full details because transit gateway will have 2 different route tables, incoming and outgoing. And from that route table, I will jump into SD-WAN. And that's the last slide for the packet flow, talking about connectivity between transit gateway and SD-WAN. You can use VPN or connect attachments between transit gateway and SD-WAN VPC. You know all the plus and minus points for both. And then we run BGP on top of the tunnel. Via BGP, we learn all the networks, and then we redistribute BGP into our protocol, in this case OMP, Overlay Management Protocol. That's a routing protocol inside of SD-WAN. And that's pretty much it. So we have C8KV running as SD-WAN router, and we can do the same with multi-region using Cloudvan, which will be the next topic. But stay with me for next slide, talking about security, and then we will jump into Cloudvan. And I do have a pointer to a GitHub repo it's a set of Terraform scripts which will allow you to build this scenario in your own environment. So now let's talk about the demonstration. It's really quick. What you see here is FMC, Firepower Management Center. That's my controller for the firewalls. And on that screen, lazy TME, I don't use 4, I use 2 firewalls, 1 per availability zone. And if I will start the presentation, then you will see that I can enable Genève with actually more or less 1 click. If you enable NVE checkmark and use the default port 6081, it will start and configure Genève protocol on that interface. Second and last step is to configure health check between firewall and AWS load balancer. That's my HTTP port running on 443 for the health check. And if I switch to my AWS management console, you will see the same configured for the target group. TCP on port 443, timeout 5 seconds, and you see 2 healthy firewalls defined in the target group. So now I will ping. Network engineer, what you do for verification? You ping from the cloud app to SD-WAN. I'm running packet capture on both firewalls, and ping doesn't work. Why? Because my policy is blocking ping by default. So let me change this. With 1 click, I will allow my ping, and I need to save the policy on the controller. And the second and last step is pushing down the policy to both firewalls. That's the deploy state. And once I deploy this new change, letting ping go, then basically you will see that my ping will work. So let me just move the browser to the right, and then while doing deployment on the right, you will see the ping going through on the left side. So that's basically the simple verification that the connectivity from the cloud to SD-WAN is now inspected, and my policy change is active. It still goes to the same firewall. There's no asymmetric routing. The second firewall does not have any packet. That's because of this appliance mode. It's all symmetric. Okay, now to Cloudvan. That's basically what we saw in the keynote today, right in the beginning. If you look at Cisco solutions for AWS, we don't have 1, we don't have 2, we have multiple solutions available before Cloudvan. We call it Cloud on-ramp for multi-cloud, and this is what we automated. That's what you saw in the beginning. You have your branch locations, you have your SD-WAN VPC, and then connected to Transit Gateway. Next solution is Branch Connect, where you go from your branch directly into TGW. So you are not extending SD-WAN fabric to the cloud. What's the difference? Well, in the first case, you can use your SD-WAN policies, you can apply your end-to-end segmentation, and you have your all SD-WAN features. Let's say you want to run forward error correction, which will actually help you if you have some traffic loss. In the Branch Connect case, you don't need it. You say, hey, Nikolai, I just want to go to the next cloud entry point, that's it. That's why you're using just a standard IKE-based IPsec into TGW. That's fine. And if you look at this screenshot from vManage, you will see the first 3 solutions, exactly what I just described, VPN-based, GRE-based, Connect, and Branch Connect. But now we added 2 additional options, solution number 4 and number 5, specifically for Cloudvan. So if you go into your vManage cloud generic settings, you will see 2 new options, both for Cloudvan. So the next question is, Nikolai, okay, what is Cloudvan? Tell me. Well, you have AWS Backbone, and you have your Cisco SD-WAN fabric. With SD-WAN and Cloudvan, you can run site to cloud use case, you can reach, in this case, from the branch in LA to any app in any region using AWS Backbone. And that's, by the way, on the right side, the new logo for Cloudvan, which is quite nice and similar to what you saw for Transit Gateway. So that's okay, but we have also site-to-site use case over AWS Core. In this case, I'm connecting London to LA via AWS Backbone. So on the business side, on the benefit side, it's really easy to stitch regions now. You might think about cost saving because we did one calculation for 100 megabit link from Asia Pac to San Jose using traditional MPLS provider, and that was around about between 10 and 15K per month. If you do the same via AWS Backbone, that will be around about 2K. And it's cost saving, but then if you know how long will it take to install MPLS router to do it and in shipment configuration, it's time in addition to money. And that's not all, because what we also see, we will create SD-WAN tunnel over AWS network. And within SD-WAN tunnel, we run BFD packets. It's a small packet sent every second. You can configure this, but let's say every second from London to LA. And every second you will know loss, latency, and delay over AWS Backbone for this particular tunnel. And we can do it per type of service. So what does it mean for you? Well, we had customers saying, well, Nikolai, full stop. Are you saying to me that now I can exactly know the loss, latency, and delay between two AWS regions using, let's say, TGW peerings? Yes. So, and that was for that customer, basically the must-have point, not to send traffic, much traffic, but the ability to see every second what is going on for my tunnel inside AWS Backbone. That was critical. And that's just the nature of SD-WAN, because we have it by default. If you enable SD-WAN, for us, AWS Core is just another transport. Like MPLS, like public internet, we have the tunnel over AWS Core network. So you can define an application and say, all right, by default, for this critical application, I will use AWS Backbone. But if SLA, let's say, packet drop or latency will be violated, let's say latency increase from 200 milliseconds to 500 milliseconds, then please reroute via public internet. That's the key benefit of using Cisco SD-WAN over Cloudvan. Now let's talk about architecture. What you see here is multiple regions, and this is AWS Backbone. You have multiple, we call it CNE, Core Network Edge routers, more or less, doing dynamic routing between regions. And that's a key difference, because if you think back and look at TGW peering, you will be down to static routing. You need to define static routes between regions, which is not the best solution compared to dynamic routing exchange here. And then you see here this CNP file, which is core network policy file, which will define your whole network. So basically, it's a YAML file which will define the whole thing. Regions, edges, segments, dynamic routing, attachments, sharing, and firewalls. All in one file, which you push down to AWS, and you have your network. Then you attach SD-WAN to it with multiple branches. And the best thing is, this all is done from one single UI, from Cisco vManage. So Cisco vManage will control SD-WAN fabric, back to my example with the policy of 200 milliseconds. That will be coming from vManage to this to this yellow Cisco SD-WAN block. And the YAML file, the CNP file, will be sent from vManage to AWS in the same moment. You can do from vManage, SD-WAN, traditional networking, and cloud networking in one shot. Typical question here is, okay, Nikolai, are you saying that you are controlling the whole infrastructure from Cisco vManage? What if my AWS engineer will go in and change something on AWS console? Because now we have split brain. We have vManage with own view to the network, and then something was changed from a different angle. What shall I do? Well, we have cloud audit. It's just a built-in functionality in vManage. By default, every 2 hours, vManage will go and check, is my view real one? Is it the same as the cloud view? And if not, right now, it will autocorrect. Some of you told us, well, please don't autocorrect immediately. I want to see the delta first and then approve. That's something we are working on. It's not ready yet, but we hear you because just autocorrect by default, display nice warning is okay, but it's not what some customers are asking. So that's why this cloud audit function is essential to keep vManage as a central place of truth. I know some of you prefer to read slides afterwards. That's why I have the next slide basically having my talking points, what I just mentioned, on one slide. So I will not go through that slide, but this is for your reference. You can read it. It's just a summary of what I just mentioned on the previous slide. So now, and I know we don't have enough time to go deep into Cloudvan implementation. Question will be, hey, tell me how Cloudvan is implemented. Well, it's more a question to AWS, not to Cisco. I can definitely talk afterwards, but what I want to highlight here is the workflow. How would you do it? And it's actually a very simple process of 4 steps. Step number 1 is you have to give permission to vManage to do something on your behalf on AWS. So you would define your cloud credentials in vManage. Step number 2 is vManage will go ahead and say, all right, thank you for credentials. This is what I see on host VPC level. So vManage will go to AWS and discover host VPCs. If you have multiple clouds, we do for multiple clouds, totally fine. You can then tag VPCs you want to connect with SD-WAN using just strong strings like production or engineering. After you tag your infrastructure, you will spin up Cisco Cloud Gateway, which is basically more or less C8KV, the Cisco SD-WAN router you saw on the previous slides. By default, we will spin 2 of virtual routers per region for redundancy. And last step, you will interconnect your cloud infrastructure with SD-WAN. So let's say you have a branch in LA with engineering folks using dedicated Wi-Fi. You map this Wi-Fi into, we call it VPN. And then you will connect this Wi-Fi segment to this cloud host VPC from engineering. Overlapping IPs, no problems, because we're using separate route tables. You can do whatever you want in terms of mapping. But how would you do the mapping? This is basically really simple, almost boring table on the bottom of the page where you have VPN 10, that will be my engineering hotspot. Then you have the next VPN, or you can have 10 different VPNs. That will be your segments on the branch side. That's your traditional network on-prem. And on the other hand, you have your discovered cloud infrastructure. So you have engineering VPC, production VPC, and all what you need to do is one click to connect sites on-prem based on, let's say, VLANs or specific segments to host VPC. So let's see how it looks. You're looking at vManage dashboard. That's the landing page for vManage. It will provide you the summary for control plane, data plane, inventory, and then you go to the cloud section for cloud on-ramp for multi-cloud. In this case, you see AWS as an example. You click on the last step, step number 4. You select your provider, in this case, AWS, and then you see this table. If you go to edit, and let's say you connect VPN 10 to test VPC as well, you click save, and then vManage goes to AWS, programs route tables, programs the whole infrastructure you need, tweaks routing between AWS and C8 KVs, and connects it for you. And I clocked it here. So basically, if I refresh the page, the success is, I think, 45 seconds. I started by, 48 seconds. Later, I interconnected my, let's say, Wi-Fi from engineering on the branch to this test VPC. If I go back to the table, now I see successful interconnection here. This is what I want to remember. And the same workflow is applicable for any of solutions we have. Because if I go back, remember, we talked about traditional solutions with IPsec tunnels directly to transit gateway, or extending SD-WAN to the cloud, or Cloudvan. Exactly the same workflow is applicable for all of AWS solutions. You just need to select in global settings which type you want, Cloudvan, or let's say VPN-based connection to transit gateway, and follow the same workflow. That's the whole idea, to hide complexity for, let's say, standard enterprise user, and use automation built into vManage for this. Okay, last slide from my side, and then I will hand over to Simarbir, is about creating a bridge between applications and SD-WAN using AWS Cloud Map. Do we have DevOps representatives in the room? How many DevOps guys? Okay. Do we have NetOps guys? For sure. Okay, thank you. So it's half-half. That's great. It's a perfect example for both. So let's assume we have DevOps guys creating the new application, like critical video communication. And they need from the network the best possible SLAs, the best quality for this new application, from the branch across the whole platform, including cloud. So DevOps guys, they don't really understand all this fancy Cisco Voodoo with QoS and traffic shaping and whatnot. It's not the job for DevOps normally. I have to admit, we saw some DevOps having full understanding of traffic shaping and queuing, but it's a special case. What we ask you guys from the DevOps guys to do one API call and register your application with a string. So you will write metadata, in this case traffic profile equal video, to AWS Cloud Map. And AWS Cloud Map is just a registration service, right? So just a list of applications with some attributes. Okay, so DevOps team is done. Now we have NetOps guys saying, all right, I see something popping up in AWS Cloud Map. And by default, we have a tool called Cloud Native WAN Adapter. We are working on integration into vManage as well. But this tool will read by default every 15 seconds AWS Cloud Map. And it will say, hey, Nikolai, I saw a new app with a string traffic profile equal to video. And the NetOps guy will say, no worries, I do have a policy with queuing, shaping, all the details related to the string. So now basically the cloud map and the cloud native WAN adapter is a translator. It's a language translator between DevOps and NetOps. Because all what you need to do is basically to write this into cloud map, so, and then NetOps guys will need to define what to do with that string. Once the policy created, it will be automatically pushed to the entire network. This is why I call it the bridge between applications and SD-WAN, because 15 seconds later after registration, worst case, because I mean it's a regular polling interval, let's say worst case 15 seconds later, we saw this new application, and typically it will take 5 seconds to apply the SD-WAN policy to the whole network. So 15 plus 5, 20 seconds later, you will have this policy for this new application in your entire network. We do have a demonstration for this case in our booth. It will be closed by 6. So come and see us at the expo. If you want to see the demo for this use case, or if you want to talk more about Cloudvan, we will stay after the session as well here. And we do have a Cisco booth dedicated for this, for both use cases as well. And details for the Cloudvan and for the automation of this case can be found at our DevNet site. It's basically a GitHub repo where you will find all the details for this cloud-native WAN adapter. With that, I would like to ask Simarbir to continue and talk about Meraki side.
Awesome. Thank you, Nikolai. That was awesome. Awesome, guys. So let's get into Cisco Meraki and AWS. Let me begin by talking a little bit about Meraki. Been at the booth, getting a lot of questions about what is Meraki, what do we do. So Cisco Meraki is a globally proven platform with inbuilt networking and security services that lets you span your SD-WAN fabric across branches as well as to a hybrid cloud environment. We do have our security and SD-WAN appliance, which is called the MX, which is used to actually build the SD-WAN fabric. But along with that, we also support a wide variety of other networking appliances like switches, our Wi-Fi APs, cameras, along with IoT sensors as well. All of this is managed through our central dashboard, which not only gives out-of-box management, but also has advanced analytics and ML, giving in high quality of experience. And finally, kind of building off of what Nikolai was talking about, we have support for open APIs, which lets you automate and integrate with other third-party vendors as well as other Cisco products. Our SD-WAN fabric is actually built on top of something called as Auto VPN. Auto VPN basically gives you the ability to set up site-to-site L3 IPsec VPN tunnels in a matter of seconds, right? You just go to our dashboard. Within a few clicks, you can set up your VPN topologies. Doesn't matter if it's just 10 sites or it's up to 10,000 sites. Automatically configured VPN configuration. So our dashboard uniquely acts as a broker between the different branch sites and will help you negotiate VPN routes, do the authentication encryption exchange to set up either a site-to-site full mesh or a hub-and-spoke topology. One thing obviously to note is even though the dashboard is acting as a broker, no actual user traffic goes through our dashboard. It's actually only just site-to-site through the VPN tunnels. And it's resilient, right? So all our MX and our security and SD-WAN appliances have dual WAN uplinks along with cellular as failback as well. So in case there is a link failure on your primary link, we will auto heal and start sending traffic across the secondary WAN link. Now let's talk about extending the security to the cloud, right? Our MX appliance also has a virtual form factor called the VMX, which can be used to extend your SD-WAN fabric back to your cloud environments. Think of essentially having like a direct connection back to the cloud environments. In addition to that, that's just on the periphery, right? So now you've gotten onto your cloud, you've established a secure connection back to the cloud. What's next, right? We go deeper into the cloud environments with our integrations with AWS Transit Gateway, as well as the new AWS Cloudvan offering. Let's get into the VMX integration with Transit Gateway, right? we're seeing more and more customers operating across different VPCs and multiple regions, right? So having a secure and reliable connection back to your workloads in different VPCs becomes key. And obviously, resiliency is also a huge factor. So if you look at the topology on the slide here, what we have here is we deploy a SD-WAN VPC or a dedicated VPC where we will set up 2 virtual MX instances across different availability zones for resiliency. In addition to that, we also deploy a transit gateway and then connect that transit gateway back to the SD-WAN VPC using a VPC attachment. On our Meraki dashboard, all the VMXs are configured as hubs, and you can set up all your branch sites to point appropriately to these hubs and distribute workloads across them. Finally, we have a Lambda function that does 2 things, right? So it'll use our APIs, fetch all the branch routes, and then program that dynamically into your VPC as well as your transit gateway route table. In addition to that, we also monitor the state of the VMX instances. And in case an instance were to go down, we will update the route tables to point to the active and the live VMX instance. One thing I'd like to highlight here is one of the reasons we had to do this is connectivity to TGW requires GRE support right now. That's something that we're working on and hopefully should have soon. All of this is automated through Quick Start, through AWS Quick Starts. And it's as simple as just going to the Quick Start page and clicking a single button, and we will set up all of this for you. In the background, we have CloudFormation templates for all of this, which will take care of your deployment as well. So next, let me go into a demo to show you how this actually works, right? So if you look at our dashboard, what I've done here is, because I'm also a lazy TME, gone ahead and pre-configured our VMXs along with onboarded a branch site to point towards those 2 VMXs as hubs. One other thing to highlight is we have this concept of network tags here, if you see on the 4th column. And we use these to essentially identify whether my VMX1 is the primary VMX or VMX2 is the secondary VMX, and so on. Go do that. So once you've done that, you go to the AWS Quick Start page. We have a official Meraki VMX Quick Start. That comes in essentially 2 options. Either you can deploy it into a new VPC or use an existing VPC if you already have that deployed. Just go to the Meraki VMX Quick Start. So once we go there, we also have a detailed deployment guide that you can refer to get more details. But essentially, if you click on one of these options for this demo, I will deploy it onto a new VPC. It takes you to the CloudFormation page on your AWS console. At this point, we do require certain parameters. For example, your Meraki organization ID, your API keys, just so that the Lambda can actually go back and talk to those resources and fetch all those routes. Specify the number of VMX instances you want to deploy. Fetch the Meraki auth token from our dashboard. So this is required to authenticate the VMX instances on Amazon back to our dashboard. I'm going to go ahead and input the second token as well. And then specify the tags. One thing also to highlight here is that the VMX offering comes in different form factors. So we do have a small, medium, large. And depending upon your throughput and VP internal requirement, those could be used. Next, we go and input your VPC requirements, so subnet CIDR for the VPC, and then different subnet blocks for your each AZ. After that, like I said, based on the instance type that you want to deploy for the VMX, choose an EC2 instance flavor, and then essentially some other parameters required for just a quick start and to set up your S3 buckets and so on. Once that's done, that's pretty much all the configuration you need to do. Just confirm everything looks okay, and then I'm just going to go ahead and hit submit, and it should deploy all these resources on AWS for me. So deploy the VMX, set up the TGW, set up the routing table, and as well as set up the routing table, as well as the secret manager and the Lambda. So once that has been deployed, you can see that my instances are active and live on the Meraki dashboard. Next, I'm just going to go ahead and check the VPN status. Here I see that my branch site is connected to both the hubs, and I'm advertising a 10.198 subnet back to the auto VPN. From the primary VMX, I can see that my VPN's up too, and next is just to make sure we have connectivity, and the best way to check that is ping. So we're going to go ahead and ping to a workload VM on my AWS environment. Here we see that the ping is working and traffic is flowing. So you can see in a matter of minutes, we were able to set up an entire new VPC, set up the connectivity from my branch side, as well as set up HA and resiliency. Now, let's talk a little bit about multi-region deployments, right? So as you might have heard from Nikolai, yes, we can use TGW to set up connectivity between different regions, but that comes with an overhead of actually manually managing all the static routes, setting up TGW pairings across different regions, defining security policies and such, which can be cumbersome, and if done manually is definitely error prone. Trust me, I've made mistakes myself. So to solve that, we've integrated the VMX with the new Cloudvan offering, which makes multi-region deployment super easy and super reliable, right? What we have here is you can deploy a single AWS core network and basically attach your SD-WAN VPCs that I showed you previously as VPC attachments back to the core network. From a workload perspective, you can have workloads distributed across different regions, and then those get attached back to the core network as VPC attachments as well. Within the core network, you can have multiple segments, right? So for example, in this diagram, we have an SD-WAN segment used for the overlay, and then you have a workload segment that obviously you use to attach to your workload VPCs and any other EC2 instances that you might have. You can split it up obviously into production, QA, dev, however you want it. And then finally, we do have security policies defined within the core network to allow traffic from my SD-WAN segment back to the workloads, and this can be more granular depending upon the use case. So we see that essentially using Cloudvan, you can define a multi-region, segmented, dynamically routed global network that traverses across the AWS global backbone and makes deployment super easy and convenient. Next, I have a quick demo that I'd like to walk you through for this. In the demo, essentially, we have a similar deployment of what I just talked about. We have a demo branch site that's advertising a 10.198.0/24 subnet. We have a core network with an SD-WAN as well as a workload segment defined. And then the branch sites connect back to the AWS environment through the SD-WAN VPC, which has a VMX deployed to it. So you're going through the Meraki SD-WAN. And then you have a workload VPC that just has a demo EC2 instance deployed on it. So let's get into the demo. This is the new Cloudvan UI. So I'll be walking through the Cloudvan UI for this particular demo. Let's see. So I've already pre-configured and pre-deployed my VMX instances. And here we see that I have a global network that's been deployed. And I have a single CNE or like an edge that's been deployed, and 2 segments, the workload and the SD-WAN segments also been deployed. So if you go here, there is different policies, and there's a nice policy versioning here as well. So you can actually look at the AWS UI and actually either configure your policy through an interactive portal, or you can also input a YAML file as well. Just to show here, these are the 2 segments as well as the destinations. These destinations are for the VPC routes for the SD-WAN VPC, and for the workloads is the workload VPC attachment. So these are the 2 attachments, one for my SD-WAN VPC and one for the workload. Next, just to verify that there is actually traffic going through my Cloudvan network, I'm going to generate some traffic, again using ping. Just to make sure the VMX is online, so we confirm that, and now let's just generate some traffic using ping. So yeah, we're sending some traffic. I can see that there is reachability. It is traversing through our SD-WAN fabric, then through the Cloudvan fabric onto the workload VMs. Now, in terms of actually looking at the usage and monitoring, if you go to the Cloudvan UI, there is a new monitoring section. And within that, you'll see some, you can monitor your traffic, you can see how many bytes are coming in, out, what the network usage looks like. And this is a logical topology of what we just deployed. Awesome. So just to kind of give you a quick idea of where we are and what our end goal and vision is. So right now, we're in the initial phases of these 2 integrations, where we're going to be using AWS Quick Starts to automate and deploy your integration with either TGW or Cloudvan. But yes, our eventual goal is to let the customers be able to use our Meraki dashboard to manage all these resources, as well as configure them so that they don't have to kind of like chair swivel between the AWS console and the Meraki dashboard. So kind of going towards more of a feature parity like Nikolai was mentioning. This is just a slide that kind of highlights all the steps that we just went through. I will leave this on, and please feel free to refer to it at the end of the session, but essentially just talks about all the steps that we just covered in the demo. Now that we've talked about connectivity and networking and how we can connect back to the cloud, let's talk a little bit about security and how we use SD-WAN and SASE to secure our workloads on the AWS environment. So if you see the architecture on the slide, what we've done is we've leveraged our partnership with Cisco Umbrella to secure any egress traffic that leaves your AWS cloud. And basically, the entire architecture is that you have 2 virtual MXs or 2 SD-WAN routers deployed in different segments. One is used for the traffic that is originating towards the internet from AWS, and then the other is used for SD-WAN connectivity back to your branch sites, right? So, if any traffic to and back from your branch sites goes over the SD-WAN fabric, and in terms of any traffic that's egressing to the internet, we have an Umbrella SIG or Security Internet Gateway connector that forms, again, an SD-WAN fabric from your AWS cloud environment to Umbrella. So traffic egressing through the AWS workloads hits the Umbrella SIG, and at that point, you can do all the policy and security enforcement to make sure your traffic that is internet bound is secure. With that, I'd like to thank all of you for coming to our session, and please feel free to stop by our booth, and These are some of the resources that you can access. We do have risk-free evaluations. Feel free to check them out along with our website and blog, and then also our quick start page for all these integrations. I think we have about like 5 minutes for questions, so if you guys have any questions, feel free to.
Okay, so let me repeat the question. The question was about using AWS backbone with Cloudvan versus public internet. What are the main benefits of using CSP backbone, and AWS is one of them, versus going via public internet, right? So it's basically, let me put it in this way. You will get, if you go via CSP versus public internet, you will get MPLS-like quality for much cheaper price compared to traditional MPLS. If you go to via public internet, then you will have loss latency and delay problems, quality problems between two options. Let me give you one example. I had a demo for the second man in the company, in our company, internally demo for Todd, and I had Sydney to San Jose. Via public internet, the delay was using standard public internet link, was about 600 to 700 milliseconds, and I was using thousandized agents to monitor this. While switching to CSP backbone, in this case AWS, we were able to reduce the latency to 175 milliseconds. So that's the benefit you get on the technical level. You don't see much traffic loss on public internet today, so it's more latency reduction, better quality compared to public internet. And again, that can be done per application. You can write the policy, not generically switching between two options per app.
So you also said there was a $10,000 to $15,000 versus $2,000. Was that the same thing as SID? Was it London to San Jose or SID?
No, it was, that calculation was done from Asia Pac region to San Jose. I don't recall the city as specifically, but Asia Pac, 100 megabit link, assuming standard utilization, so it's not 24 hours full speed, reasonable data, and that was, I think it was something between 10 and 12K per month plus 5K activation fee, depending on the MPLS provider as well. But if you go down to AWS costs, where you have to calculate multiple things like transit costs, etc., but you are down to 2K, and then you have to add licenses for SD-WAN routers as well. So I think it was around about 2.5K total. Sure.
So I just have a scenario where we do multiple VPCs per region. Right now we are not using SD-WAN with our cloud solution. So we've got transit gateway for every region. So we're routing traffic for all the VPCs to separate transit gateway for regions. All transit gateways are connected to each other in software, right?
So I can probably start and then you can
Sure,
chime
yes,
in.
yeah.
So the question was about throughput related to multi-region deployment. So let's say we have multiple regions, and even if we will forget about SD-WAN on traditional networking side, what is the best scalable way to interconnect and have the best performance between the regions? So we have 50 gig limitation, what you mentioned, that will be per attachment, right? And the question is, if I use, for example, Cloudvan, will I still have 50 gig between regions? And the answer is yes. But now, the second question will be, okay, I do have 50 gig on the cloud side, that's great. How would I send it back to the data center or to on-prem? If you take CSR or C8KV as an example, it will give you 5 or 10 gig performance per router. But now, if you're using VPN attachments, you're down to 1.25 gig. So that will be the bottleneck. You can switch from IPsec to GRE tunnel, which will give you 5 gig. So that's kind of the bandwidth differentiation cloud side, where you have 50 gigs, and then if you go down, then you're limited more or less to performance of single GRE tunnel.
So, how about the traffic between our regions that is transition to the SD-WAN traffic that we have, but still be given the throughput of 50 Mbps?
Yeah, so you will have, yes, you will have your transit gateway connected to SD-WAN VPC, right? And if you connect this via connect attachment, then basically for connect attachment, you need to do VPC attachment first, right? So you have 50 gig here, and then your bandwidth limitation will be single tunnel, but you can do multiple tunnels to multiple routers. Does that make sense? Okay.
Yeah, just to kind of add, like going from like a TGW, what you were talking about, to like a Cloudvan implementation, there shouldn't be any performance degradation for you on your cloud resources.
Okay, officially we don't have time for the question, but you have one. So probably we can just retouch on your question.
It's kind of an architecture question around. So the core network edge, I mean, essentially, to me, it acts as a transit gateway, but it hasn't the additional functionality that you guys outlined. So am I missing it in that if I use a core network edge, would I still have a transit gateway?
Pretty much.
But that will be underlined. You will not see the transit gateways. For the Cloudvan, it will be hidden. And yeah, so. It will be using, yeah. Sure, thank you.
Thank you, guys.